Hi, thanks so much. I'm really excited to be here. This is, I believe, the 6th time I've spoken for Jared at conferences and meetups, and it gets more fun every time. It's my first time in DCR, so really excited to be here. So my talk starts with the experience of who's heard of the Tidy Tuesday project? Isn't it fantastic? It's a project run by the R for Data Science online learning community, and every week they release a data set to the data science community and say, do anything you can. You can analyze it, make graphs, do analyses. And what inspired me to do is start opening the data set each week and then recording myself analyzing it. So I've ended up doing 36 Tidy Tuesday screencasts in the last year. So I spend an hour with each data set, dive in, learn some things about it, and post the recording on YouTube. So it's been really fun, but so here's an example where I'm so like how I'm exploring a data set, trying out building a network graph, I think, yeah. And then I started working from there, and it's been really fun to learn about myself and learn about some of the how I feel about what we're working with new data and really practicing that skill. But it's also been a blast to hear from people that say what they learned from the screencast, because it's not always what I expect. One thing I found out is that all of us are walking around with tricks, things we know how to do with R, or often in my case with the Tidyverse, that we might not think of as an obscure trick, but that is a critical part of our workflow and might help other people. So with that, I decided I'd go kind of the clickbait route and say, here are my 10 tricks that only a Tidyverse user will appreciate. Number 6 will blow your mind. And really just walk through rapid fire a series of things that you may or may not know that you can do in the Tidyverse. Each of the times I'm actually really interested, this is the first time I'm giving this talk, I'm really interested in learning what does everybody already know, what might be extremely obscure, what's somewhere in between. So I'm going to ask about each trick who has already heard about it. Sound good? So these are the 10 tricks that are going to be combined into kind of themes. First, a couple of tricks I found around counting and summarizing data. Second, one about ggplot2 for visualization and forecasts for categorical data. And third, 3 tricks from TidyR that are some of the slightly less well-known functions from the package. So first, I'm going to start with my favorite function, count. Who has used count in dplyr before? Fantastic. So Hadley Wickham has said that most of data science is counting and sometimes dividing. And I find you can get a really long way just with counting data. So in fact, I did a little analysis of all of the screencasts, the aforementioned screencasts that I've done, and actually found that count was the 4th most used function in them after mutate, filter, and group by. So I really do love counting. What would I do with count? This was one of the, a lot of the examples I'm going to show come from my Tidy Tuesday screencast just because it's a lot of code I have lying around where I've used these tricks. This was one from the first screencast I did where I counted the number of times number of graduates of each major. So in this case, this was a table that divided college majors down into categories and showed here's there are 10 majors in agriculture and natural resources, 8 in the arts. So some of you may have used count this way. Did you know it has 3 additional arguments? Sort, weight, and name. Sort lets us say, well, we're going to count the number of times each category appears, but then we're going to sort the result in descending order to find the largest first. Weight means that instead of finding the number of observations, I'm going to sum up a column. In this case, I say the weight is total, which means I'll sum up the total number of graduates column and find the number of graduates in each. And third, the result doesn't have to be named n, it can be named graduates. So which you can give a name equals graduates. I think that's new as of dplyr 0.8.0, fairly recent. So really in this trick, you get 3 tricks for the price of 1. Who's used sort in count before? Who's used weight? Who's used name? It's awesome. So that was the first trick. The second trick is another way to use a group by or count. We've seen that you can count one of the existing columns. For example, here was a data set of bridges from Maryland in Maryland and what year they were built. So I had this count where I'd say how many times was each built. But I might not want to count how many bridges were built in each year. But I might not want to count it by year. I might want to count it by decade. So in the same process of the count, I can create a new column, kind of like a mutate then account. So and then it ends up with a data set that's actually aggregated by decade, 1900, 1910, 1920, instead of being aggregated by year. So in fact, there's a trick, 10 times year, that's truncated division 10. That's a way you can aggregate years in a decade, which offers a bonus trick within this one. Who already knew that you could create new variables in a group by or count? It's actually more obscure than I expected, but that's a really fun trick. It saves you an extra step of creating a variable. So in a graph like this, I would end up a data set like this. I might end up taking this, doing a geom line, and so the number of bridges built in each decade. Third is add count. Who's ever used the add count function in dplyr? This one was added, I think, about 3 years ago. It is a little bit more obscure. Who has ever had to do this? A group by, mutate, then ungroup, where all you're adding in is n equals n. It's really helpful, and we're going to see a couple cases where it's helpful. This is a 3-step process where I'd say, where I want to add this n column and say here are the 4, in these 4 observations, the total for that group is 4. In the 2 for B, it's 2. In this one for C, it's 1. And that can be done in 1 step of add count columns. So taking 3 steps and putting them into 1. Where I find this really useful is to combine it with a filter. So if I say add count and then filter, so this was a data set of space launches for particular US space vehicles. And I wanted to, and because I said add count to a particular variable, then do a filter on that n, I was able to visualize only the vehicles that had at least 20 launches. So add count and filter is a combination I like to play with here. A third way that I really like to aggregate data is with Summarize, is creating a list column. This is a relatively recent behavior of dplyr. I'm not sure if it was introduced last year or the year before, but you can use Summarize to create a list column. So I'm going to pull out a Tidy Tuesday data set of New York City restaurants. And this was actually of inspections of them and showing what, for this restaurant, how many times was it inspected and what was the average score, where a higher score means more violations. Now, I could find the average inspection score with a group by and a Summarize. So a group by, Summarize, mean, average score, and I've added a column called AVG score with that value. But did you know that if you put a list as the output in that Summarize, you don't end up with a value, you end up with a list column. So this field in the result is actually a list, and every one of these objects is a t-test. So we can put kind of anything into that Summarize equals list, and anything we put in there is going to be turned into an object in this list column. So why would we want to create a table of many objects? That would cover a much larger scope than what I have time to talk about today. But here's one example is we could take those, use the broom package to tidy them, and then visualize multiple models, such as here. It shows what types of restaurants have the most violations. Turns out juice smoothies and cafes the fewest. Indian, Latin, Caribbean, Spanish, Thai have some of the most. And you get individual confidence intervals for each of them. So that comes from visualizing many models. There's a chapter of this in R for Data Science, chapter 25, that if you're interested in visualizing multiple models, is really worth checking out. Who has created list columns with Summarize before? Trick number 5 is a story of a couple of tricks in one that combine to form something I do a lot, especially in these screencasts. It's actually my favorite plot. So when I ask someone what their favorite plot is, some people say something like, oh, I really like a really particularly complicated plot. This is Menard's Napoleonic war. And some people could praise a plot like this, but the truth is I really like a plot like this, a bar plot that's sorted. So this actually, in fact, I showed this plot earlier where I said what functions in dplyr do I use the most, and it's a combination of 4 steps. A count, an FCT reorder, a reorder. Who has used FCT reorder or built-in reorder before? Yeah, it's so amazing for visualization. It turns this column into an ordered factor, which allows you to visualize it in this kind of descending way. I throw in a geom call. Who has used geom call as opposed to geom bar? So if you've used geom bar before, you might have to say stat equals identity. More recently, you can say geom call instead of like geom column for that. And who has used coord flip? Coord flip is great because I think it's so much easier to read, and you can fit some more text when you have a horizontal bar plot. So that combination of tricks forms a graph that I make a lot. In fact, these are just 5 examples from some of the screencasts that I've done. Of here's a bar plot, here's the frequency of certain categories. You can stack them. You can do really a lot with this graph. Who has used FCT lump before? Continuing our tour of forcats. So what's great about lump is that you might have a lot of levels, and you want to combine some of them into other. So this is from one of the our studio. This is from one of our studio's fantastic cheat sheets for factors with forcats, and they show if you have a factor of like a couple of levels, you can FCT lump it and take all the less common levels and combine them into other. So I'll show an example from a screencast. I'm going to stand by this one. I'm having a little trouble with the clicker. So this was a data set of horror movies that included their reviews as well as their rating, like PG, PG-14, R, PG-13. And if I just did a box plot, it would look like this. It would look like they'd be kind of out of order. There are a few levels. There's only one PG-rated horror movie in this data set. And there'd be these couple of levels, and it wouldn't be really useful. So, but with 2 steps, FCT lump, and then as we saw in the last trick, FCT reorder, we end up with a much more interpretable graph that combines all the rare levels into other. So I really like FCT lump for box plots, bar plots, counts, things like that. Who's used log scales before? So this is a tidyverse trick in the sense that it is a ggplot2 function. But it's really also a data science trick that I think is really important and sometimes underappreciated. So I've actually somebody said that if I had to give important advice to new data scientists, I might start with something like, well, you must start with a specific scientific question. Then I say, nope, it's actually the number 1 advice is try putting your axis on a log scale. Why is it important to put an axis on a log scale? I'm going to show a couple of data sets where it's really pivotal. One is this. Was a wine data set where we said, what is the distribution of prices of wine? And if we looked at it on a regular scale, it would see everything interesting is crammed into one tiny part of the graph. Put it on a logarithmic scale, one on which every fixed amount of space on the x-axis represents a multiplication of the value from 10, 100, 1,000, and suddenly becomes kind of more of a bell curve shape. This is a distribution statisticians call log normal, meaning that the log of the data is approximately normal. Why is it important for it to be normal? Well, what if we were trying to predict a wine rating from the price of wine? If we made a scatter plot like that, we said, here's the price, here's how experts rated this wine, everything will get crammed together, and the prediction wouldn't be very effective. In fact, it would quickly go off past 100. Whereas if we do a prediction of the wine rating based on the price of wine, we get what amounts to closer to a correlation, to we see like a linear correlation, and a better prediction. And indeed, in the screencast I found, it was considerably more accurate to predict wine rating from the log of price rather than from the price. And once you start visualizing it with log scales, you can see that. So much real-world data is log normal. I sometimes suspect a lot more real-world data is log normal than normally distributed. Examples are GDP per capita across countries. This was a visualization from one on plastic waste, and we saw that on the x-axis is log GDP per capita of a country, y-axis is log CO2 emissions, and if you had them in regular scales, everything would have been crammed into the lower left. Population across cities or countries, income across people is log normally distributed, revenue across companies. A lot of data. Usually these days, if I open a data set and it's, I almost don't expect a numeric column to be, unless it's something artificial like a test score. I often expect it to be log normally distributed and throw some scale x log 10 onto the graph. We're moving on to a couple Tidyr functions. Who has used the crossing function from Tidyr? Crossing is amazing, and what it does is fairly simple. What it does is it takes vectors and finds creates a tibble with every combination of them. Here there's A, which is 1 to 3, then a couple other vectors, and it turns it into all 24 combinations of A, B, and C, the inputs. Has anyone used expand.grid? Expand.grid is the basic, our equivalent. Crossing is a little more convenient for working with other Tidyr functions because, among other advantages, it returns a tibble and doesn't convert strings to factors. It's really hard to explain in 2 minutes what crossing is so useful for. It's really worth a talk or a blog post on its own. But some of the things I would do with it are try every combination of two numbers so that you can visualize, ggplot a mathematical curve. When it's used alongside augment from Broom, it's really good for showing how a prediction comes from the input parameters. In this case, this shows that over time, the probability of getting a season 2 has become more dependent on audience opinion. And there's a really sophisticated area of tidy simulation where you can use crossing to create all combinations of possible inputs and end up doing some tidy simulation on top of those. All I can do for now is advertise the existence of the function. It's been really powerful. I'm going to end with 2 more Tidyr tricks for cleaning your data. Who has used separate from Tidyr? This looks like about half the room. And this is from another one of our studio's cheat sheets. Separate takes a column that, something like a ratio, and splits it out based on a regular expression or based on a string. So it's hard to appreciate how important this is until you've worked with some data where a lot of stuff is crammed into one column. This was a data set I had to work with during my graduate work, and everything to the right of name is all one column split up by pipes with lots of really interesting information. Back when I was in graduate school, I actually went back to my code and found this awful line for extracting one value out of there, the one that I really needed. Today what I would do is I would say separate. I would tell it all the columns I want to be divided into and give it a regular expression, a string pattern that would say here's how I'd split it, and get it in 5 separate columns. So once you've worked with data in the wild that has these combined together, separate is a really handy trick. The last trick I'll introduce is extract. Who has used extract from Tidyr before? Extract is fantastic when you have some data that's not necessarily separated by a delimiter, but kind of trapped within some pattern of a column. So here, it was a data set of Bob Ross episodes, and we had these codes, these season and episode. So what I would do here is extract from that episode column the two, I'd say there's a regular expression for S something, E something, and from that I get 2 columns of season and episode number. It's even really helpful that by saying convert equals true, I get those columns as integers. It actually figured out that those were integer columns and converted them so that I wouldn't have to do that myself. So steps like this can take 2 or 3 or 4 steps of data cleaning, turn them into 1. So that concludes my 10 Tidyverse tricks. Now, why do I like to focus so much on tricks? What is so great about them? Is the Tidyverse nothing more than a bag of tricks? My take is that the Tidyverse is greater than the sum of its parts. I think that when you combine all of these ways of doing something, make every one of them a little bit easier, and ensure that they all work together fluently, these benefits, they're not just a little bit of convenience here, a little bit of convenience here. They really accumulate and keep you in your data analysis flow. And that's one of the reasons that, that I've really liked learning tricks from people when I pair program with them, when I talk to them at a conference like this, when I read other people's code, and I've really loved sharing these 10 tricks with you today. Thank you.